A power amplifier is an electronic device that increases the line-level audio signal to loudspeaker level. The power amplifier is the last processing device in the signal path prior to the loudspeaker. Power amplifiers differ by way of their class, power rating, number of channels, specifications, and any additional features incorporated into the unit's design. Power amplifier class types are designated by the design of the output stage and how the signal amplification actually occurs. The most popular classes include A, B, AB, C, D, H, and S. These classes are not generally important to the sound engineer. They are more important to audiophiles and those who can discern an audible difference between classes. An amplifier's power rating indicates the output power in watts based on the load that the amplifier sees. An amplifier will output more power to a load with a lower impedance. For example, a QSC PLX1804 will output 600 watts into an 8-ohm load, but will increase to 900 watts if the load is 4 ohms. Most power amplifiers are stereo, meaning they output 2 channels of audio. Amplifiers also come in multi-channel versions that have 4, 6, and even 8 output channels. Multiple-channel power amplifiers are advantageous when low to mid-wattage is required and equipment rack space is limited. Amplifier specifications include the device's power rating, input sensitivity, distortion, damping factor, and frequency response. Specifications document the device's performance and sonic quality based on industry standard tests. For example, amplifier output ratings are determined by applying various impedance loads to the output when driven with a 1-volt input level. An amplifier specification should be considered when selecting an amplifier, but should not be the sole criterion. Critical listening tests and proven performance should be highly considered. An increasing number of manufacturers are integrating control and monitoring capabilities into their amplifiers. Via computer software, the operator can communicate with the amplifier over a network and monitor the input level, output level, gain, heat load, and other such features. Software configurations provide for easy control and tailoring of the amplifier's features. Recent developments in amplifier design have seen circuits integrated that detect overload on both the input and output stages, virtually eliminating short circuits from damaging the amplifier. Heat sensors incorporated into the amplifier can tell the amplifier to shut down in case of excessive heat due to shorted loudspeaker cables or too low of an impedance caused by too many loudspeakers being connected to the amplifier. An amplifier's output is dependent on the impedance load of the connected loudspeakers and the input voltage level. Impedance is the audio term for resistance. The impedance of a loudspeaker is the load that the amplifier sees and attempts to drive. Most amplifiers maintain stability driving loads down to 4 ohms, with some remaining stable down to 2 ohms. It is helpful to think of impedance in terms of a valve. When the valve is fully open, there is no impedance, but close that valve 1/4 of the way and there is resistance to the flow. Connecting a loudspeaker to the output of an amplifier creates resistance, and hence a load is applied to the amplifier. The knobs found on the front or rear of the amplifier are attenuation controls. Their purpose is to cut the incoming signal in order to adjust output level. Amplifiers are automatically set to 100% gain. The attenuation knobs simply control the amount of signal reaching the amplifier's output stage. Most modern amplifier designs incorporate several operating modes that manipulate the input and output signal configurations. The two input configurations are stereo and parallel mono, and the output configurations are stereo and bridged mono. These settings are typically selected via switches on the rear of the amplifier. Attention should be paid to proper wiring of both the input and output connections. Improper wiring can cause severe damage. There are two basic input configurations for a two-channel amplifier, stereo and parallel mono. Stereo mode implies that each channel will receive a different input signal. In parallel mode, each amplifier channel receives the signal connected to input 1. Parallel mode eliminates the need for Y cords and adapters when a common signal is required to feed both amplifier channels. There are also two basic output configurations for a two-channel amplifier, stereo and bridged mono. In stereo mode, the amplifier has two output channels, each working independent of the other. In bridged mono mode, the two channels become a push-pull configuration and thus combine into one high-power output. Proper settings are critical to the amplifier operation. Before the amplifier is energized, the user should select the correct configuration mode, stereo, parallel, or bridged mono. Prior to energizing the amplifier, the control knob should be set to 0. Once the configuration settings are set, the loudspeaker cable should be tested for shorts. This can be checked with a speaker tester or basic volt-ohm meter. An easy way to set the amplifier control knobs is to play a CD or music source through the mixer with the faders and controls set to nominal or unity gain. Turn the amplifier controls up until the desired system volume is met. Listen to the music and ensure no distortion or clipping is occurring, especially at high levels. Leave the amplifier controls at that setting, and then adjust all volumes at the mixing console. This will ensure an acceptable gain structure, preventing clipping and distortion. There are three main causes of clipping and distortion: pushing an amplifier beyond its rated output, overpowering the loudspeakers, or sending a distorted signal to the amplifier. This normally occurs when you want more volume and the amplifier is already working at full output. Overdriving the amplifier will clip the output signal, causing the loudspeaker to distort. This will cause amplifier malfunction and possible loudspeaker damage. Clipping is easily detected when critical listening is practiced by the audio systems engineer. The amount of heat generated by power amplifiers can be quite immense. Proper ventilation around the amplifier and conditioning of the room where the amplifiers are located is critical. Overheating greatly decreases the lifespan of the amplifier. Most manufacturers provide specifications and guidelines for proper heat dissipation. Amplifiers require large amounts of clean AC power. High-power amplifiers require their own 120-volt, 20-amp circuit, while medium-power amplifiers can normally be paired on one 20-amp circuit. Remember, the power amplifier is dependent on the AC power source to produce the power it was designed to deliver. If the AC source is not clean, or if proper grounding is not implemented, buzz and hum will make their way into the audio system. It is recommended that a power conditioner be placed in front of all amplifiers. Power conditioners maintain constant voltage levels and offer sequential powering so that each piece of equipment can be powered in sequence, which helps prevent damage to audio system components. The process of selecting an amplifier begins by determining the power handling of the loudspeaker you want to drive. In the case of an MD-F122 loudspeaker, 400 watts RMS at 8 ohms. Naturally, one would select a 400-watt amplifier to power this loudspeaker, but this is not necessarily correct. In reality, you would want to use an amplifier that will produce up to 800 watts at 8 ohms, which would provide 3 dB of headroom. A little-known fact is that the main cause of loudspeaker damage is using an amplifier with too little power, not too much. If an amplifier is overdriven and is clipping the output signal, DC power is transmitted across the loudspeaker inputs, potentially damaging the speaker drivers in the process. Many amplifiers include additional features, including DSP input modules, network control and monitoring, output sequencing, and hibernation modes. These features are all intended to make the sound engineer's life easier by allowing extra control and the ability to monitor the amplifier's performance visually by a computer in the sound booth. These features also increase the amplifier's longevity with increased lifespans. A power amplifier is an electronic device that increases the line-level audio signal to loudspeaker level. Power amplifiers differ by way of their class, power rating, and number of channels. An amplifier's output is dependent on the impedance load of loudspeakers connected to the output and the input voltage level. There are 2 basic input configurations for amplifiers, stereo and parallel mono. There are also 2 basic output configurations for amplifiers, stereo and bridged mono. Before the amplifier is energized, the user should select the correct configuration mode, stereo, parallel, or bridged mono, and check the loudspeaker lines for shorts. Amplifiers generate heat, and care should be taken to ensure proper ventilation around the amplifier. Amplifiers are dependent on their required AC power in order to produce the output they are designed to deliver.